Okay, here we go. Number 6. What is the expected number of people you would have to sample to find somebody with the same birthday as yours? So, assuming 365 days in the year, so the probability of success will to have the same birthday as yours is 1 over 365. The probability of failure would be 364 over 365. So the expected value, the expected number you would have to sample to find someone with the same birthday as yours is Q over P. So that's 364 over 365 all over 1 over 365. When you divide by a fraction, you multiply by the reciprocal. And that is equal to 364. You would expect to sample 364 people before finding someone with the same birthday. Oh boy, wordy, birthday as yours. Good. I hope that's the right answer. Yes, 364. That's good. Okay, is that okay for number 6? Okay, so let's do number 9. It is estimated that on a daily basis, 15% of the customers at a local supermarket use express cash out. What is the probability that one of the first customers on a given day uses one of the first 5 customers on a given day uses the express checkout? So, okay, so he could either he could either be the first customer, or he could be the second customer, or he could be the third customer. I'll put express here, express here, express here, or the fourth customer, or the 5th customer. 1, 2, 3, 4, 5. So, if he's the first one, it would be 0.15. Uh-oh. That should be 0.15. Maybe I can write that a little bit better. This is 0.15. If he's a second customer, it be probability of failure, then 0.15 or 0.85. I'll just write that as squared, right, because it has 2 spots, times 0.15, or 0.85 cubed times 0.15 plus 0.85 to the 4th times 0.15. So let's see what we get when we multiply that out. 0.15 plus 0.85 times 0.15 plus 0.85 squared times 0.15 plus 0.85 to the exponent 3 times 0.15 plus 0.85 to the exponent 4 times 0.15. I get 0.5563. Is that okay? So it's one of the first 5. So you start with what's the first one, or the second one, or the third one, or the 4th one, or the 5th one. Can I answer any other question? No? Are we? Yep. Number 5. What are the odds against your rolling doubles in fewer than 4 rolls of dice? So to find the odds against it, we're going to have to find the probability x is less than or equal to 3, right? Because in this situation, here, let me draw a little picture first. In order to roll within fewer than 4 rolls of dice, it's either you get it on the first one, you either get doubles on the first one, or you get doubles on the second one, or, oh, it's fewer than 4. You get doubles on the third one. So the waiting time here is probability x is less than or equal to 2. So that's going to be probability of doubles is 1 over 6 plus 5 over 6 times 1 over 6 plus 5 over 6 squared times 1 over 6. So we have to calculate the probability before we can calculate the odds. So 1 divided by 6 plus 5 divided by 36 plus 25 divided by 216, and we get 91 over 216. That's the probability. So the odds in favor, now this is where x is less than or equal to 2, is equal to 91 over 216 all over 1 minus 91 over 216. And that's going to be 91 over 2. Let's see, 216 minus 2. Okay. Oh, odds against. This is odds for. They want odds against, so it's the reciprocal. Sorry, I read the question wrong. So odds against x less than or equal to 2 is the reciprocal of that, 125 over 91. Was there anything else in the homework that I could go over? And this is where x is the number of non-doubles before a double occurs, right? X is number of non-doubles, for lack of a better word, before doubles are rolled. Before doubles are rolled. Sorry, I'm just trying to squeeze it in here. Okay, x is the number of non-doubles before doubles are rolled. Anything else? Yep. 6. Number 10. If the probability of Michiko getting an A, here's the question. If the probability of Michiko getting an A in her math test is 0.6, what is the probability she will get her first A on the second test? She will get an A on one or more of the first 3 tests. So let's see, because that's kind of tricky. Number 10, A. All right, so the probability x equals 1, right? She gets it on her second test, is 0.4 times 0.6, which of course is 0.24. Where x is number of tests before her first day. Part B. She will get an A on one or more of her first 3 tests. Well, I don't think this is a waiting time question. Yeah. So probability, we'll say A is greater than or equal to 1 is equal to the probability of A equals 1 plus probability of A equals 2 plus probability of A equals 3. So here A is getting an A on a test. Yeah, okay. Let's do both and just compare because that's kind of an interesting point. I'm going to do yours next, okay? So this is um, 3 choose 1 or 1 minus 0, my bad. This is a binomial situation the way we're treating it. 1 minus the probability A equals 0. So this is going to be 1 minus 3 choose 0, 0.6 to the 0, 0.4 to the 3. And that's 1 minus, I get 0.936. Okay. So let's do it the waiting time way. Probability x is greater than or equal to 0 is going to be the probability x equals 0 plus the probability, that's where x is the number of tests before the first day, x equals 1 plus the probability x equals 2. So on the first one it'd be 0.4 plus point, no, the probability for getting an A is 0.6, right? 0.6 plus 0.4 times 0.6 plus 0.4 squared times 0.6. 0.6 plus 0.4 times 0.6 plus 0.4 squared times 0.6. 0.936. If you were to draw a tree diagram, A naught, A naught, A naught, I just want to compare it to a tree diagram, see what. So 0.6, 0.6, 0.6, 0.4, 0.4, 0.6, 0.4, 6.4, 0.6.4, 4. Okay, if we do, well, we did the 1 minus 0 A's, right? That was here. So if you get an A on the first one, that includes this branch, right? You get an A on the second one, that includes this branch. And then you get an A not till the third one, this branch. I'm just trying to tie them in together, you know. So this probability here is 0.6, right? And then this one is 0.4 times 0.6. Wait a minute, 0.4 times 0.6. And then 0.4 times, yeah, this is 0.4 times 0.6, so it includes all of those. And then 0.4 squared includes this branch, and it leaves that one out. I don't know, it's just kind of interesting the way that works out. Oh, so you went 1 minus test on the first one? Yeah, that's what, yeah, I did that up there. Yeah. Okay. Anything else before we move on to hypergeometric?